Ever get the feeling that there's like a whole world going on around us that we just don't notice? I
Yeah.
mean, think about it. Like all those plants and trees, even the little bugs crawling around, it's like they're all talking to each other in some secret language.
Well, they kind of are. And today, we're going to try and decipher some of that language, right? Diving deep into the world of secondary metabolites.
Secondary metabolites. Okay, now I remember from some of the stuff we were looking at before, we've got these basic building blocks of life, like the proteins and the carbs and all that. But these secondary metabolites, they're kind of like the extras,
Right.
not strictly essential for just staying alive, but
But they play this crucial role in how organisms interact with their environment. It's like, think about it. Everything from defending themselves to attracting mates, even dealing with harsh weather, it all comes down to these chemical compounds.
so they're kind of like the secret weapons that give organisms an edge.
Exactly. And the more we learn about them, the more we realize just how sophisticated and diverse these chemical strategies really are. Okay, well, let's break it down then. Where should we start? Like, when you think about the challenges an organism faces, what's one of the first things that comes to mind?
Well, for most organisms, survival means not getting eaten, right? So defense is a big one,
Makes sense. You're constantly on the lookout for predators.
right? And plants, for example, they can't exactly run away, so they've evolved all sorts of clever chemical defenses.
Oh, yeah, like those toxic compounds, right?
Exactly. Things like nicotine in tobacco or caffeine in coffee, those are classic examples. They act as these really effective deterrents to herbivores.
It's like a built-in pesticide, right?
Kind of, yeah. But then you also have things like tannins. Those aren't like immediately toxic, but they interfere with digestion. So over time, they make the plant a much less appealing meal.
So it's like, yeah, you can eat me, but you're going to regret it later.
Yeah, exactly. And what's really cool is that this isn't just a one-way street. Some insects, for instance, have evolved ways to actually detoxify these compounds.
Mhm.
So it's this constant back and forth and evolutionary arms race, if you will.
It's like they're battling it out on a chemical level. And it's not just the big herbivores they have to worry about, right? What about all the microscopic stuff?
Oh, yeah, definitely. When plants are attacked by, say, bacteria or fungi, they can produce these compounds called phytoalexins.
Phytoalexins, okay.
Think of them as the plant's rapid response system. They're these antimicrobial agents that get activated when there's an infection.
So they're actively fighting back against these invaders.
Exactly. And beyond just direct attacks, secondary metabolites also play a huge role in how organisms compete with each other.
Oh, interesting. How so?
Well, some plants engage in what's called allelopathy. This is where they release chemicals into the soil that actually inhibit the growth of surrounding plants.
So it's like a chemical warfare almost.
In a way, yeah. It's a more subtle form of competition, using chemical signals to gain an advantage in the struggle for resources like sunlight and nutrients.
So it's not just about defending yourself, it's about getting ahead of the competition too. But it's not all about fighting and repelling, right? I mean, think about all those bright colors and enticing smells we see in nature.
Right, and that's where secondary metabolites come in to play a totally different role, more like advertising.
Advertising. Okay, I'm intrigued. Tell me more.
So you've got the vibrant scents of flowers,
Mm.
right? Often due to these volatile organic compounds like terpenes and phenolics. And those act as signals to pollinators. It's like they're saying, hey, nectar here, come and get it.
It's like a chemical welcome mat.
Exactly. And similarly, the bright colors of ripe fruit, thanks to pigments like anthocyanins, along with their delicious aromas, they attract animals who will then disperse the seeds. It's all about, like, using chemical cues to facilitate reproduction.
So they're manipulating the behavior of other organisms with these chemicals.
In a sense, yeah. And it's not just limited to plants. Think about, like, pheromones in animals, right? They use those to attract mates.
Oh, yeah, it's all about communication, right? It's sending signals across the landscape.
Exactly. And in some cases, it's even about communication between different species. Like when a plant is under attack by herbivores, it can release volatile organic compounds, or VOCs.
VOCs, okay.
And these VOCs, they act as a warning signal to neighboring plants. It's like a chemical early warning system saying, hey, danger's coming, get your defenses up.
That's amazing. So it's not just about protecting themselves, they're actually looking out for each other.
Right. And sometimes those same VOCs released by a damaged plant can actually attract the natural enemies of those herbivores. So it's like they're calling for backup.
Wow, that's incredible. It's like a whole network of communication going on out there.
It really is. And we also see this in symbiotic relationships, like the exchange of flavonoid signals between legumes and nitrogen-fixing rhizobia bacteria in the soil. It's
Right.
like a chemical handshake, establishing a mutually beneficial partnership.
So these compounds, they're not just for defense or attraction, they're actually facilitating these complex interactions between different organisms.
Exactly. And it doesn't
Mhm.
stop there. These compounds can even help organisms cope with, like, the physical environment itself.
Oh yeah, like dealing with harsh weather conditions and stuff.
Right. Think about the damage that UV radiation can cause. Well, pigments like flavonoids and carotenoids, they act as natural sunscreens, absorbing those harmful rays,
It's like built-in SPF for plants.
pretty much. And when organisms face stresses like drought or pollution, phenolics can act as antioxidants, helping to neutralize damaging reactive oxygen species at a cellular level. It's like a built-in defense mechanism against environmental stress.
It's incredible, really, when you think about how many different roles these so-called secondary compounds play. It's like it's not just about surviving, it's about thriving, adapting, and interacting with the world around you.
And that's the key takeaway here, right? While they may not be essential for those basic metabolic functions, secondary metabolites are absolutely vital for an organism's ability to adapt, survive, and interact successfully within its environment.
It's like they're the unsung heroes of the natural world, constantly working behind the scenes to keep things running smoothly.
Exactly. They're a testament to the power and sophistication of nature's chemical toolkit.
And thinking about all these intricate chemical interactions happening all the time, I mean, it just makes you wonder, right? Like, how could a deeper understanding of these natural compounds, how could that inspire new approaches in fields like medicine, agriculture, or even, our efforts to protect the environment?
Oh, absolutely. The possibilities are vast, and it's an area ripe for exploration.
Definitely something to ponder long after our deep dive today.
Absolutely.